Hello there, I'm Mark Xupei from the Chair of Software Engineering at ETH Zurich. In this video, I would like to show you some results of our research in automatic program fixing, particularly our tool called AutoFix, which can automatically propose fixes to program faults. Program faults are expensive. They were said to cost the US economy an estimated $59 billion annually. And there are too many of them for us to fix manually. Many widely used programs are shipped with non-bugs due to the lack of manpower to fix them. For better productivity and software quality, it would be great if we could automate, even if only partly, the process of program fixing. In the past few years, we have developed techniques and a supporting tool called AutoFix to automatically suggest fixes to program faults. AutoFix takes a buggy program and a group of test cases as input. The program should be equipped with contracts like pre-post conditions and class invariants. The contracts are used as the oracle for the success of test cases. A test case is passing if it does not violate any contract during execution, or failing if it does. The input test cases typically contain both passing and failing tests. The tool then analyzes the execution of the test cases, locates the possible causes of the failures, and produces a list of code snippets as valid fixes. The fixes are valid in the sense that replacing the original buggy code with any of them will enable all the test cases to pass. Fixes that do remove the old bug while not introducing any new bug are called proper fixes. For the moment, AutoFix supports generating fixes to programs in the IFO programming language. IFO is a general-purpose object-oriented programming language, and a contract is a built-in concept of that language. As for the test cases, it doesn't matter where they come from. They could either be written by programmers or be produced by some automatic mechanism. In the following demo, I will be using another tool called AutoTest that was developed in our previous work to automatically generate test cases for fixing. AutoFix and AutoTest together actually allows us to automate the whole debugging process from finding faults to fixing them. Now, let's take a look at how to use AutoTest to produce test cases and how AutoFix uses those test cases to suggest fixes automatically. In this demo folder, eve.exe is the executable for the IFO verification environment, where both AutoFix and AutoTest are implemented as command line tools. Also in this folder, I have prepared a small IFO project. In the project folder, we have an IFO project configuration file and an IFO class file. The ifgens folder is created by the IFO compiler during compilation. Let me open the project in Eve. The project defines only one trivial class called application. In IFO, members of classes are called features. A feature is a query if it has a return type, or a command if it hasn't. I will be using a class called two-way sorted set as the example. Since it's defined in the library, to include it in the project I need to explicitly reference it, for example by declaring a local variable of its type in feature make. Class two-way sorted set is an IFO implementation of sets using a doubly linked list. Inside a set, the elements occupy positions 1 to count, where count is an integer attribute storing the total number of elements in the set. The integer attribute index is an internal cursor useful to navigate the content of the set. The indexes 0 and count plus 1 correspond to the positions before the first element and after the last element. Before and after are Boolean argument list queries that return true when the cursor is in the corresponding boundary positions. The cursor is off any element if either before or after is true. Next, I will run AutoTest on class 2 assorted set for 30 minutes to find out first if there's any fault in the class, and second, in the case of yes, to collect test cases that can be used for automatic fixing. I will use this AutoTest batch file in the demo folder to run AutoTest. Let me get it started now. I will explain the commands in the batch file in a second while AutoTest is running. Here is the content of the batch file to run AutoTest. In the first command, after the if executable, we have the information about our working project, the switch to run AutoTest, the length of the testing session, 30 minutes here, the file where all the generated test cases should be serialized, some other arguments, and in the end the class to test. When testing is finished, we run AutoTest again using the second command to generate classes for test cases, one class for each test case. Here we have again the information about the working project, the AutoTest switch, the path to the serialization file from the testing session, and the folder to store the test cases. We store them in the tests subfolder inside the demo folder. There are different ways to organize the generated test cases. We use this flag to tell AutoTest to organize the test cases in a way that serves fixing better. Now AutoTest is still testing the class. Let's wait till it's done. Now AutoTest has finished and generated test cases in the tests folder. Each subfolder here corresponds to a feature that experienced failure during testing, and failing test cases are grouped according to the signature of the failures. For example, failing tests on feature move item have failed with two different signatures, as indicated by the names of the two subfolders here. Each subfolder contains all the passing test cases on feature move item, as well as those failing test cases with the same failure signature. Here, test cases with this capital F in their names are failing tests, and those with capital S are passing ones. When preparing test cases for fixing, AutoTest doesn't store test cases for features that never failed during testing. What does feature move item do, and why does it fail in certain cases? Let's take a look at the feature. Move item takes an element v from the set and moves the element to the immediate left of the internal cursor. To this end, it saves the cursor position as the local variable idx, performs a linear search for the element v using the internal cursor, removes v from the set, restores the original cursor position to the value saved in idx, and then puts v back to the set before the internal cursor by calling putLeft. One problem with this implementation is that if the internal cursor is before the first element when the move item is invoked, then putLeft would be called on a set whose cursor is at the before position, and that will trigger a precondition violation. The precondition of putLeft requires not before, because conceptually there's no position to the left of position 0. This is exactly the reason for the failure with signature move item C3B2. Now I will use AutoFix to automatically generate fixes to this fault. AutoFix.bat is the batch file I will use to run AutoFix. Again, let me start fixing first. I will explain what's in the batch file in a second. Here is the content of the batch. Following the if executable and the working project information are the AutoFix switch, the maximum length of the fixing session, 10 minutes here, location of the test cases to be used, the path for the fixing report file, and some other arguments to fine control the behavior of the tool. AutoFix has finished, and it has suggested 10 valid fixes. Let's look at a few of them. Here is the first fix. Command force moves the internal cursor to its right position. Forcing the cursor when before is true at calling put left will avoid the failure and still preserve the correct semantics of move item. So this fix is proper. For an example of valid but not proper fix, let's look at the last valid fix. With this fix, the feature doesn't call put left at all if before is true. Such a fix surely avoids the failure we had before, but it also introduces a new fault by not putting the element v back into the set. AutoFix automatically orders the valid fixes so that the better ones appear on the top of the list. Then the programmer decides in the end which one, if any, to apply. So this is how AutoTest and AutoFix work together to automatically detect program faults and suggest fixes. Recently, we applied AutoFix to 204 faults detected by AutoTest in real-world projects. AutoFix was able to suggest valid fixes to 86 or 42% of them. Manual inspection confirmed the fixes to 51 faults out of those 86 are proper, meaning their quality is comparable to that of what programmers would write. To know more about AutoFix, please visit the homepage of AutoFix at this URL. Thank you for watching.